Hey ladies and gentlemen, this is lesson 3.6, proportional and non-proportional relationships. I'm the Berman Nation. We're going to roll through this information, make things easy for you hopefully. This should sound somewhat familiar as to what we've done already throughout this chapter. Alright, so a big learning target. We're hoping at the end of this lesson you can actually say these words. I can determine if a relationship is proportional or not. Alright, so for things to be proportional, we're going to have something that sounds very familiar. The relationship is proportional if it fits into this form. If it goes into the y equals kx, if you see a graph that has the value of 0, 0, or the line goes through 0, 0. Now, yes, 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 and yes, you have heard this before. So this is the exact same thing if it goes through 0, 0 of the y equals kx as the direct variation equation. I know, sounds exciting. Okay, so anywho, so examples that you will see in your assignment or on the test are going to be kind of like this. They're going to ask you, is this relationship proportional? So the number of hours that we drive and the number of miles that we drive. So is it proportional? What we're going to do is we're going to look at things just like we did with the previous lesson. You're going to notice that they're all going up by 50 every single time. Yay, up by 50. Up by 50. And up by 50. So you'll notice that it is going up by 50, and these are all going up by 1. But the thing that we're really going to look at is these are my x's and these are my y's. We're going to look as these numbers to determine if something is proportional. So if I have a 50 divided by 1, is that the same proportion as 100 over 2? Or 150 over 3, or 200 over 4. If it is, we're going to say yes, it's in 50 miles in 1 hour. That's an hour. Or if we just said 50 over 1. So that would be another way to show that things are proportional. If I were to make an equation out of this, it would look like this. Y is equal to the number of miles that we drive times the number of hours. So if I want to find out how far we drive in 10 hours, we'd plug a 10 in for the x and do 50 times 10. All right, so the same exact process over here. You notice that they're all going up by 3. Yay, we're happy. But if we look at the proportional relationship, you'll see that 9 divided by 1 is not the same thing as 12 over 2, or 15 over 3, or 18 over 4. These things are not equal to each other. Therefore, it is non-proportional relationship. Now, although it is a linear relationship because we're going up by a constant rate on both the x and the y. So that's a non-proportional relationship. So let's check out this one. If we're going to write an equation for this graph, and then find out if it is proportional. Now the very, very first thing we said, that has to go through 0, 0 to be proportional, so we're going to put a big fat no down, but we need to make ourselves an equation as well. So we need to find how much is it increasing by. So notice that my x values are going up by 1 from these two. So we need to find out what my y value is going up by, which is also going up by 1. So we have ourselves a increase of 1 over here. We went to the right 2 and we went up 2. So my rise over my run is a slope of 1. So that's my k value. The change of y was 1. The change of x was 1. So my k is equal to 1. So my equation would start with y is equal to a 1x. Now if we plug in a number 1 into the x, do we get the value of 2? The answer is no. In order for us to get that, we'd have to do plus 1 more. So if you look at these numbers, we have a -1, we have a 0, we have a 2, and a 3 for my x values. For my y values, we have a 1, a 2, is that a 4, and a 5. So if we look at these numbers, if I plug in a 1 in, I should be getting this answer for my a negative 1, I should be getting this. If I put in a 0 in, I should be getting this. Is it happening right now? The answer is no. We need to do a +2. So that's going to make this work out. Good thing we check to make sure that it actually fit. If we plug in a 2 in for x, 2 times 1 makes a 2, plus the 2, so we should get up to this 4. So now it's working. So this is our equation for the graph. It might help to make a table of the values that you've been given or where the line is crossing nice and beautifully on your grid. All right, folks, that is this information. This is the Berman Nation. We're signing off. I don't know if this assignment's correct, so don't start doing it yet. You might want to check with what my website says. All right, folks, we're signing off. Peace.